Data matching is a commonly studied problem in computer science and statistics. It is the process of inferring which entries in the same or different databases correspond to the same real-world entity. This is an example of an individual, John Public, appearing under different names in the same database. These entries have to be reconciled before analysis. Darknet markets are online marketplaces like Amazon or eBay, but they have several features that provide anonymity protections. As a result, these marketplaces are used primarily for the sale of illicit products such as drugs, weapons, and stolen personal information. Sellers can operate multiple accounts on the same or on different marketplaces, and this is where the matching problem arises. The goal of this paper is to match these seller accounts to figure out if they belong to the same real-world seller. This is useful to researchers, law enforcement, and marketplace patrons. Researchers might be interested in getting an accurate idea of the number of sellers involved. Law enforcement have an interest in linking online identities to real-world identities, and information from different accounts can be combined to provide leads. For marketplace patrons, matching accounts is important to verify the identity and credibility of sellers. Data matching is a common problem, but what is less common is the adversarial component that is present in the marketplace context. In particular, sellers might have an incentive to conceal their identity. For example, a given vendor might compartmentalize different lines of businesses to increase their operational security. Conversely, some vendors may attempt to impersonate well-known accounts to defraud customers by registering the same handle on different marketplaces. In this paper, we used data scraped from 12 marketplaces from 2011 to 2018. We use a supervised approach where labels are generated, for example, using PGP keys. We then use a combination of random forest classifiers and hierarchical clustering to match over 22,000 accounts. One way that we deal with the adversarial component is to select features that are costly for adversaries to mimic. Our models can achieve more than 75% precision and recall. Performance is superior to using a baseline of account IDs that are commonly used in the literature. In limited cases, ground truth for whether accounts belong to the same sellers are available when a seller is arrested. We have information in 7 cases, and in 4 out of these 7, the model manages to find some of these links independently. Finally, we manually reviewed some false negatives where the model predicted pairs to be extremely unlikely to belong to the same seller, yet they shared the same PGP key. We found that 26 out of 117 of these manually reviewed pairs had the same key only because the Dutch National Police had briefly taken over these accounts and changed the key to theirs. For more information, this is our paper. Thank you for watching.